Section 1.5. In this section, we're going to examine angle pair relationships. We're going to have some new terminology and some old terminology, and then we're going to use those angle pair relationships to find angle measures. So here's a warm-up from what we worked on with angle bisectors and angle addition. So why don't you try this problem, and then we'll go through the answer. So if you did this problem correctly, then the first one, since it is using angle addition, we'd set the two expressions of the smaller pieces of the angle equal to the large angle addition. And when we solve, we get x equals 6, and when we plug them in, we get 28 degrees and 41 degrees. In the second example, it's bisecting it, so it means it's two equal pieces. Those small expressions for the angles are equal to each other, so we set them equal to each other and solve for x, and then plug the value back in to find 1/2 of the angle and then double it. So hopefully that is going well for you. We're going to move on to angle pair relationships. So we're going to define the different types, and then we are going to use them to find angle measures. These first ones are probably pretty easy for you. You've probably done them before. So complementary angles are two angles with a sum of 90 degrees. So those two angles that add up to 90 degrees can be similar to this first example, like angle A and angle B. We would say angle A and angle B are complementary, because they're two separate angles, and when we take 30 degrees plus 60 degrees, they add up to 90 degrees. We can also say that angle B is the complement of angle A. So sometimes you'll hear it stated that way. It means kind of the same thing. In the second example, you can have two angles that add up to 90 degrees that are within the same picture. So what we have here is we have angle MAT, and we have this angle TAH right here. Angle TAH. Guess I could clean this up a little bit here. And they are complementary. And how do I know that? Well, here's the key. We can see this marking right here. That is the marking for a right angle. That marking means right angle, which equals 90 degrees. So angle MAH is 90 degrees. So also we have supplementary angles, and supplementary angles are two angles with the sum of 180. And just like with complementary angles, they can be two separate angles drawn. So angle A and angle B are supplementary. We know that because 112 plus 58 equals 180 degrees. Or they can be drawn in the same picture like this second example. Now, when we have these two angles right here drawn within themselves, and they form what's called a linear pair. So this angle right here, angle NAT, NTA. So we have, use a different color for this. We have angle NTA, and we have this other angle in here. We have angle ATE right here. They are an example of a linear pair. And that is an example of two angles that are also supplementary. So those two angles are a linear pair. That is this specific piece right here. A linear pair are two angles that share a side and are supplementary. So the side that these angles both share are right here. So that ray TA is shared by both angles and they form a straight line. And it kind of describes itself if you think about it. A lot of students miss this, but linear means line, and a pair is two. So you have two angles that form a line, that is a linear pair. And we know that this together, this is a straight angle, so that's how we know that is 180 degrees. So the other half is also 180 degrees. So there's supplementary angles, and then there's kind of a special case of supplementary angles called a linear pair. So now let's use some of the information we just went over to solve some problems and find some angle measures. All right, so again, notice this marking right here, 90 degrees. So that means if both of these are making a straight angle right here of 180, then that means the other half also has to be 90. So let's look at what else they gave us. They gave us that angle KAI. So angle KAI, this angle right in here, is 25 degrees. So now they want us to find KAC. Well, we already found KAC because we already noticed that we had a right angle on one side, so there has to be a right angle on the other in order to make the straight angle of 180. So that is just 90 degrees. The next thing they want us to find is they want us to find IAE. So that is this angle right in here. Well, how are we going to find that? Well, notice that these two angles right here are the same. They are marked with one tick mark. So we know that this whole angle right here has to be 90 minus 25, which is 75 degrees. So this angle is 75 degrees. So if those two angles are congruent, then you have to divide that by 2 and you're going to get 32.5 degrees. So that's 32.5 for each of those. Not only IAE, but also EAJ. All right. So the next thing I want to talk about is adjacent angles. And this, you really need to pay attention to these definition pieces. They have to share a vertex. So notice, angle 1 and angle 2, okay, have the same vertex. So if we look at angle 1 right here, this is angle 1, that's its vertex in yellow. If we look at angle 2, here's angle 2 in blue. That angle also has the yellow for its vertex. So they are sharing a vertex. They also have to share a side. So if we look at this side right here, they are both sharing that side. So they share a common side. And then the last piece says no interior points can be in common. Well, here are all the interior points of angle 1. Well, there's a lot more that I didn't draw. And here are all the interior points for angle 2, and none of them are in common. So those interior points, none of them are in common, and that's how you know they're adjacent. Remember, when I think about adjacent, I think of like next to each other. So they are next to each other, and they share a vertex, a common side, and no interior points. They do not share. So let's take a look at some of these examples. Here are two examples where, yes, these are adjacent angles because they share this common vertex right here. They share this common side right here, and the interior points of this angle are right here, and the interior points of this angle are right here, and there are none in common. So this next one is not. Well, here's their interior points. right here, and here's the other interior points. So they do have no interior points in common right here for example 2. They do actually share this common side right here, but what they don't share is a common vertex. So they don't share a common vertex. And that's why they are not. Here's one vertex, here's the other. So that's why that's a no. Now, this example can be yes, or it could be no, and I'll explain, okay? So if we look at how it could, some of them could be anyway. If you look at angle ICM, so angle ICM, and we look at this other angle, MCA. So this angle, oops, I didn't get my color that I wanted. So MCA, they share this common side right here. They have the common side, they have the common vertex, and they don't have any interior points in common. So angle ICM and angle MCA are adjacent angles. And there are other ones as well, okay? We could also look at angle MCA, which is the blue one again that we already drew. And we could look at ACH, and they also are adjacent angles. But what if we look at angle MCH? So angle MCH, and we'll go back and use one that we have used, angle ACH. That's this one right here, are not. They're not adjacent. Can you figure out why? So if you look at the vertex piece, here's the vertex of, here's the vertex right here of MCA, or sorry, MCH, this should be, I'm sorry, I labeled this wrong. This is an H down here, so this should be an H. Maybe that's just my messy writing, but if we look at this angle right here, those are all the interior points for that angle. And you can see that some of the yellow interior points were the same as our ACH. So the reason they're not adjacent is because they have interior points in common. So these can get kind of tricky. All right, and we're going to look at vertical angles next, and that's another angle pair, and these vertical angles are going to come up again and again and again. And the name might be strange, but if you look at the angles formed here, like angle 4, and you look at angle 2 right here, they look the same, and they actually are the same. Vertical angles are opposite angles formed by intersecting lines. So what you have here is you have this line right here, get a different color here, we have this line right here, and we have this line right here. So we have these intersecting lines, and the angles opposite each other are always going to be congruent. So we can say that angle 2 and angle 4 are vertical angles. They're called vertical angles. But we also have another pair of vertical angles. We have angle 1 and angle 3 are also vertical angles, and they will also be congruent. Angle 1 and angle 3 are vertical angles. And the thing to keep in mind is not only the name, but this big piece right here is that they are always congruent. And we're actually going to prove that later on. But I can give you a quick little maybe example proof. This doesn't prove it for every case, but I think I can convince you by just putting a value. If angle 2 is 40 degrees, well, if angle 2 is 40 degrees and angle 1 right here and angle 2 right here form a linear pair, then angle 1 has to be 140 degrees because 1 and 2 together form a linear pair, a straight line, 180 degrees. They have to add up to 180 degrees. Well, so now if you look at angle 1 and angle 4, they also form a linear pair. So this also has to be 40 because they also still have to form a linear pair right here. And so if we keep going with that same linear pair strategy, those opposite angles will always be congruent. So let's try some examples combining some things together. So, first of all, we're supposed to find A, B, C, and D, and you don't always have to find them in that order, okay? But if you use vertical angles, we can see that these angles are across from each other and will be congruent. So that makes C 58 degrees. And this angle right here and this angle right here are across from each other. They're formed by these intersecting lines. So look for intersecting lines, so angle B will be 63 degrees. So I got the easy ones, but how do I get A? Well, again, remember back that these three angles together make a straight line. They make 180 degrees. So if you already know 63 and 58 added together, then you have to subtract. So 63 plus 58 plus angle A has to equal 180 degrees. So now when I take 180 degrees and subtract, that would give me 59 degrees. And then D is opposite it, so it will also be 59 degrees. It's a vertical angle. So we'll do some with some algebra pieces here. And that's the basics of what we're going to cover. We're just going to continue on doing some examples from using our different angle pairs. So you have to look at the diagram, or you have to look at the given information to see what are you given. Well, I can see that this is a straight line. So these two angles right here form a linear pair. They add up to 180 degrees. So that means 11x plus 23 added with the other angle, 7x plus 13, has to equal 180 degrees. So now I can combine like terms and continue solving for x. So x equals 8. So I found x. Now figure out what they're asking you to find. They're not always going to ask you to find every single angle. So they want me to find the measure of DIN. So DIN. So that means it's 7 times my x value of 8 plus 13. And that gives me a measure of 69 degrees. Now they want me to find FID. So FID. Well, the easiest way to find that, since I know they have to add up to 180, is just take 180 and subtract the 69 degrees, and that gives me 111 degrees. Or you could plug that value in, 11 times 8 plus 23. So now let's see what we have on the next one. we have the word that these angles are complementary. Complementary means they add up to 90 degrees. Supplementary is 180. So I know that the measure of angle A plus the measure of angle B has to equal 180 degrees. So my equation would be 6x plus 5x plus 9 has to equal 90 degrees. So again, we continue solving for x, and we get x equals 9. So now, again, see what they want you to find? They want you to find the measure of angle A, so that's going to be 4 times 9. That's going to be 36. They want you to find the measure of angle B. Again, you could plug in that 9, 5 times 9 plus 9, but otherwise just subtract from 90, and that would give you 54 degrees. Here's another one. Look at the clues. Now they are telling you that these angles are a linear pair. So remember, linear pair, it's a line. Okay, so it's a straight line. So it's 180 degrees. So that means the picture would look something like this. You'd have angle A and you'd have angle B. Now that might not fit the problem, but that's just what's going on. So what you're going to do is you're going to take the two angles and add them together and set them equal to 180. So why don't you see if you can finish solving the algebra piece on this one? And here x would equal 12. Now find A and B. And you should get 136 and 44. So I'll fill in the work on the rest of that problem if you didn't get it correct so that you can find your mistake. That is the end of lesson and section.